Vanakkam. Welcome to this video on biomechanics. We have been looking at introductory mechanics with an introduction to statics and dynamics. And we were looking at some simple problems in mechanics. We saw one problem in the previous class. In this class, we will see one more problem. Here is a problem in statics. The question is, draw the free body diagram and calculate the unknown reaction forces and moments wherever applicable in the following situation. Okay, this is the situation. There is a force that is applied here which I do not know, and there is a known 5 Newton force that is applied at an inclination of 60 degrees to the horizontal in this way, and there is a 7 Newton force that is applied perpendicular to the bar. These are all separated by 0.5 meters. How many unknowns will be there in this case? And it turns out that there is a connection, there is a joint, there is a hinge sort of thing here, there is a pin sort of thing that is there. So, there will be reactions here. How many reactions will be there? Because this bar can rotate like this, it is like this, I am holding, it is like my left hand like this, I am holding like that and I am applying a force. So, it can rotate like that. That means its moment will not be there, but it is preventing movement in or acceleration in this direction or in that direction, right, that is being prevented. That means that there will be two reactions. Also, in addition, there will be one more force, unknown force. So, there are two reaction forces Rx and Ry that will be there and one unknown force that will be there. Okay. So, let us draw the free body diagram. These are the distances. There will be an Rx and there will be an Ry. Okay, I am going to call this point as O, and at that end point A, that point I am going to call as A, there is an unknown force that is acting which I do not know, and at point B here there is a force of 5 Newton acting at 60 degrees to the horizontal as shown, and at point C there, which is at that other end, there is a 7 Newton force that is acting. Okay. Now, I can try to write out the equations of static equilibrium for this case. Let us write, let us assume that xy axis, and I can write sigma fx equal to 0, because this object does not accelerate in the x direction. The sum of all the forces in that x direction will be 0. What are the forces in the x direction? Will F be in the x direction? The answer is no, because it is obviously in the negative y direction for the direction shown. Okay. And 7 Newton is in the negative y direction. Will Rx be in x direction? Yes, because that is Rx, that is a reaction force in x direction. So, that is Rx and that is in the positive x direction. Ry obviously is Ry, it will not have an x component. Will 5 Newton have an x component? The answer is yes, 5 Newton has an x component. And will it be positive? The answer is yes, because I have to resolve this, right. This force, if I resolve, that will be like this and like this, is it not? If I resolve, it will have a negative y component and a positive x component. So, I will write this as Rx minus 5 times cos 60, is it not? This angle is 60 degrees, is it not? So, this distance then is cosine of 60, cos 60 times 5. But will it be negative? No, right? It will be positive, because this is in the positive x direction, right? It will be Rx plus 5 times cos 60 is 0. Anything else I have missed? The answer is no. Okay. So, this is 0. This will straight away give me Rx to be minus 2.5 newtons. What does this mean? Minus 2.5 newtons. That means this force is going in the opposite direction. Is it? Yes. It is not that this force is being applied here like in this direction with positive magnitude, but rather with positive magnitude at this point there is a pull that is happening towards a negative x direction in this direction for the same magnitude. Okay. So, Rx is minus 2.5 newtons for that positive x axis, is it not? Now, I can write the next equation of static equilibrium as sigma Fy equals 0, because this object does not accelerate in the y direction. The sum of all the forces in the y direction will be 0. What are the forces in the y direction? That would be minus F. Why minus F? Because F is in the negative y direction, because this is positive y, F is in the negative y direction. So, minus F plus Ry. Why Ry is in the positive direction? Because it is given. I have assumed Ry to be in the positive y direction. You always assume the unknowns to be in the positive direction. Okay. Anything else? Minus 7 newtons. Okay. Minus 7, because that is acting at C. Anything else? Because this 5 Newton will have a negative y component, right? That is minus 5 times sin 60, is it not? We saw that. That will be minus sin 60 times 5, right? The whole thing is 0. This problem does not seem like so simple. Why? Because there are 2 unknowns and only one equation. How do we solve this? Okay, let us first write out this equation. Let us write out this equation properly. That is Ry minus F is 7 plus 5 sin 60. I can actually compute 5 sin 60 using a scientific calculator and sum it. So, I can find this as Ry minus F is some 11.3 newtons. Are we done? The answer is no, because I have to find the Ry and F. I do not know how to find it, because I have found the previous equation is in Rx. That is not very helpful for me, because there is no Rx term in this. So, that means that I have to write out the third equation of equilibrium, which is sigma m about O is 0. This whole thing can rotate, and I am taking moment about this point O, right? That is counterclockwise considered positive. If I consider, then that would be this F will be causing a moment F times 0.5 in the counterclockwise direction. That would be F into 0.5. Okay. This minus 5 sin 60, this vertical component will be causing a moment in the clockwise direction with what momentum? With a momentum of 0.5, is it not? So, and that will be in the clockwise direction. So, that will be minus 0.5 times 5 sin 60. Okay. and this 7 Newton will be causing a moment in the clockwise direction with a momentum of 1 meter, and that will be a clockwise moment. So, that will be minus 7 times 1. Anything else? There any other force? The 5 Newton force in the x direction and Rx will not cause a moment. Okay. So, I am writing this as 0. Now, it seems to me like this equation has only one variable, is it not, which is f. I can simply solve for f using this. How? F is 7 plus 5 sin 60 times 0.5, the whole thing divided by 0.5, is it not? You can compute this using a calculator and you realize f is actually 18.33 newtons. Now, substitute this f in this equation, which is Ry minus 18.33 is 11.33. So, Ry is 11.33 plus 18.33, that would be 29.66 newtons. This is Ry. What is the question? Calculate all the unknown reaction forces, right, or all the unknown forces. Reaction forces, all the unknown forces. In this case, we have found that as Rx is minus 2.5 newtons, Ry is 29.66 newtons, and F is 18.33 newtons. The question is, why did I choose to find moment about O? Why not any other point, right? Because if you choose to find moment about any other point, it turns out that Ry will also cause a moment, Rx may also cause a moment if you are taking it about the width of the bar. In this case, let us assume that the width is 0. Other unknown forces may also cause a moment, then it will become two equations in two variables. It will be slightly more tedious, right. So, for the sake of convenience, if I choose a point at which these two reaction forces have 0 momentum, then what happens? All these two moments disappear, and I have one equation in one variable which I can quickly solve and get the value of f, which I can then plug in into the previous equation and find the value of Ry. So, it is a matter of convenience. So, how do you know before you solve the problem where to choose your point? How do you know? You actually do not know when you start, but after you observe you realize, or after you write out the free body diagram, you realize if you choose a point at which there are many unknowns acting, it is convenient to choose that point to take the moment about. You can technically take the moment about any point, but it is convenient to choose a point at which many unknown forces are acting. Of course, this is only a rule of thumb. This insight on where to choose this point about which you take the moment will come only when you solve a lot of problems. This is a simple problem. Practice many more problems and you will get that insight as to where do you choose. Okay. So, with this we come to the end of this video. Thank you very much for your attention.